Tulsiramji Gaikwad-Patil, College of Engineering and Technology, Nagpur. And today I am going to discuss about the nozzle efficiency. Before the nozzle efficiency, I want to discuss about what is nozzle. The nozzle is nothing but it is a increase the velocity or increase the kinetic energy and drop in the pressure. It is known as a nozzle. Now look at here. This one is the entry point of the nozzle and this one is the exit point of the nozzle. The nozzle is nothing but it is increase the velocity like this and drop in pressure. This one is a nozzle. अगर ये नोजल है तो सम अमाउंट ऑफ द फ्रिक्शंस भी हो गए, इसके अंदर कुछ फ्रिक्शन लॉसेस हो गए. ड्यू टू द फ्रिक्शंस हमें एक डायग्राम मिलता है यहाँ पे. दिस डायग्राम इज नोन एज अ एचएस डायग्राम. This one is a enthalpy entropy diagram. Enthalpy entropy diagram. The nozzle efficiency is nothing but it is the ratio of the actual enthalpy drop or actual enthalpy to the isentropic enthalpy or ideal enthalpy. The actual enthalpy means this one is the actual enthalpy. Actual enthalpy. And isentropic enthalpy. Isentropic enthalpy or ideal enthalpy. Right? This is nothing but the efficiency of the nozzle. The efficiency of the nozzle is nothing but it is the actual enthalpy drop to the isentropic enthalpy drop. Now look at here. इस एचएस डायग्राम में कुछ कांस्टेंट प्रेशर लाइन हम इस तरीके से ड्रॉ करते हैं. दिस वन इज अ कांस्टेंट प्रेशर लाइन फॉर द एचएस डायग्राम लाइक दिस. नाउ लुक एट हियर. हियर इज अ isentropic enthalpy. This point is a 1 point, this one is a 2 and this one is a 3 point. This one is a isentropic, मतलब the entropy will be constant at that point. S2 is equals to S1 is equals to S3. This is the isentropic enthalpy drop. 1 to 2 is the isentropic enthalpy drop and 2 to 3 is again isentropic entropy drop. Isentropic enthalpy drop. Like this. What is the actual enthalpy drop? The actual enthalpy drop due to the frictions in the nozzle. This one is a 2 dot and this one is a 3 dot. This is the actual enthalpy drop. Put the value in the term of the enthalpy. This is the actual enthalpy drop. What is the actual enthalpy drop? 1 to 3 dot is a H1 minus H3 dot is a actual enthalpy drop. 1 to 3 dot is the actual enthalpy drop. And 1 to 3 this is a isentropic, that means entropy will be the constant. This one is nothing but this is the H1 minus H3 like this. This is the efficiency of the nozzle. This is a very important formula of the efficiency of the nozzle. Now look at here. If we have only 2 pressure line, अगर हमारे पास 2 प्रेशर लाइन होगी तो कुछ तरीके से हम फॉर्मूला क्रिएट करेंगे. दिस इज अगेन एंथैल्पी एंट्रोपी डायग्राम. We have 2 pressure line. This pressure number 1 and pressure number 2. Like pressure 1 is a P1 and this one is a pressure P2. What is the isentropic enthalpy drop? The isentropic enthalpy drop is nothing but this is a 1 to 2 is the isentropic enthalpy drop. What is the actual drop? The actual drop is nothing but this one is the actual drop. 1 to 2 dot is the actual drop. What is the nozzle efficiency in this diagram? Diagram number. This one is the diagram number 1. What is the actual enthalpy drop? The actual enthalpy drop is nothing but it is a H1. Nozzle efficiency is equal to the H1 minus of H2 dot. This one is the actual enthalpy drop. What is the isentropic enthalpy drop? The isentropic enthalpy drop is this point to this point is the isentropic enthalpy drop. This one is the H1 minus H2. It's the very important formula of the nozzle efficiency. We have a 2 pressure line and we have a 3 pressure line. 2 pressure line and 3 pressure line. That's enough to calculate how to calculate the nozzle efficiency from the constant pressure line 2 to 3 pressure line and 2 pressure line. Okay, now thank you. The numericals. A stage of the steam turbine is supplied with the steam at a pressure of the 50 bar at 350 degrees Celsius and exhaust at a pressure of 5 bar. The isentropic efficiency of the stage is 0.82 and the steam consumption is 2270 kg per minute. Determine the power output of the stage. Determine the power output of the stage. Now look at here the given data. Given data in this question says P1 is equals to 50 bar and P2 is equals to 5 bar and the temperature is given T1 is equals to 350 degree Celsius like this, and the nozzle efficiency or isentropic efficiency is equals to the nozzle efficiency or isentropic efficiency is equals to the 0.82. The efficiency is given in these questions. And now what is the required, and determine the power output of these stages. Power output of these stages. Power output of these stages. Listen here. This is the HS diagram from the Euler chart. You can use the Euler chart. This is the H and this one is the S diagram. Enthalpy entropy diagram. Now look at here. The pressure line is like this. The pressure line is the like this. Right? Now what is the mass flow rate in the question is given? The mass flow rate is given in the question 2270 kg per hour. Kg per hour is a given. Sorry, kg per minute is the given. You can convert in the kg per second. Mass flow rate is equal to 2270 into 60, it is kg per second, like this. Now here the pressure is a P1 is a 50 bar and pressure P2 is equal to 5 bar. Draw the pressure in this line. This one is a pressure P1 is equal to 50 bar and this one is a pressure P2 is equal to 5 bar, like this. Now here pressure is a P1 is equal to 50 bar, then the temperature is equal to 350 degrees Celsius. Like this, here the temperature is a like this 350 degrees Celsius. You can use the Euler diagram. Now find out the value of this temperature 350 and 150. Now look at here. This one is a 50 degree and one touch the point. यहाँ पे कोई आपको पॉइंट मिलेगा, इस पॉइंट से आप सीधे राइट हैंड चल जाइए तो यहाँ पे आपको H1 की वैल्यू मिल जाएगी. ये 1 to 2 था. 1 to 2 is a isentropic heat drop. Right? Isentropic heat drop. The efficiency is nothing but it is the actual heat drop to the isentropic heat drop. Isentropic heat drop. Like this. What is the isentropic heat drop? The 1 to 2 is the isentropic heat drop, but this 1 to 2 dot is a actual heat drop. Like this. Now look at here. Actual heat drop means H1 minus H2 dot over the H1 minus H2. Now find out the power output of the stages. The stage number 1 to 2 is a power output. What is the power output? The power output is equal to the mass flow rate into enthalpy of this stage. This one is a H1 minus H2 dot. Right? Now, you can find the value of the H1 minus H2 dot is equal to the efficiency is equal to H1 minus H2. Now, you can calculate this enthalpy at the point 1 and enthalpy at the point 2 by using the molar chart. Now, here pressure is equal to 350 degrees Celsius and temperature is equal to 350 degrees Celsius and pressure is equal to 50 bar. You can find out the value of H1. Like this, temperature is 350 degrees Celsius and the pressure is equal to 5 bar. You can find out the value of this H2. Like this. Now, this H1 is equal to the 3130 kilojoule per kg Kelvin by using the Mole's chart. And H2 is equal to like this 2670 kilojoule per kg Kelvin by using the again Mole's chart. Mole's chart. Now you can calculate, put this value in these equations and you can find this one is a H1 minus H2 part. Now 0.82 into H1, this is 3130 minus 2670 like this. Now put this value in these equations and use the power output. Power output is equal to this value 2270 into 60 into this value is equal to the 0.82 into 3130 minus 2670. Now the exact power output is equal to this one is a 15 watt, 15 point something watt. This is the actual answer of this question. Okay, thank you.